Hello, everyone. Welcome. This is Sri Krishnamurthy, the host of the Quant University Speaker Series. And today we are extremely happy to have Rami Krispin from the open source community, who has been contributing so much in terms of tooling. And I had Rami as a guest speaker in one of my classes at Northeastern University. And it was very well received by all my students. They learned a lot. He had put together a whole application on energy forecasting and time series modeling. And that's how I got to know Rami. And we thought we'll invite him to talk about his experience in his last 30 days. As the COVID era is kind of slowly kind of normalizing, life is normalizing in the United States, and people are taking up 30-day challenges in terms of diet and exercise so that they can get out more. Rami has taken a 30-day challenge to enhance his visualization skills. And how do we look at various aspects of data and present them in various forms? So welcome, Rami. Thank you for taking your time. I know it's early in the morning for you. I hope it's not too early and you had your coffee. So we'd love to kind of hear from you. So before we get going, we will briefly tell you a little bit about the Quant University Speaker Series. So we started out in last summer when COVID hit, and we've been hosting these weekly series, and we've had more than 40 sessions. And we're very grateful to all the speakers and the community to have supported us over the last year. And we continue to do this. We will continue to host these weekly speaking sessions so that we can share the knowledge from what's actually happening in the field, but also bring in thought leaders and experienced professionals who've been working in these areas to share their knowledge. As you all know, Quant University is an education-focused company. We started out in 2013, and we are based out of Boston. We do a lot of programming on various topics, primarily in the intersection of data science, machine learning, and finance. And we have a lot of certification programs. So please check out quantuniversity.com. And I'll tell you a little bit about some of the things we've been doing. We are very excited to announce our second summer school. Last year, we had a wonderful turnout, and we also had many new courses we offered over the summer. And this time around, we are going to be doing a machine learning bootcamp, which is going to start in June. And it basically is a 12-week program, 3 weeks of introductory data science materials, and then you have 9 weeks of machine learning and AI, primarily geared towards financial professionals. A lot of case studies, and we are partnered with Premier to do this. So if you're looking to kind of take a 90-day challenge on building out machine learning applications, please join us. The second program is primarily for experienced professionals in the risk area. As you all know, many artificial intelligence and machine learning products are coming into the financial services world. So we have put together 3 programs: one, risk and machine learning models, stress scenario testing and evaluation, primarily focusing on how do you test machine learning models. The second one is an algorithmic auditing course. And that's something we have been focused on the last year or so, as we have seen a lot of emphasis on explainability, bias, and various aspects of the machine learning model. So we have a course on algorithmic auditing. And the third one is a model risk management course that's primarily geared towards model risk management professionals who are working with machine learning models. So I hope you can join us for one or all the 3 courses. There's a discount if you join for all the 3 courses. And last but not least, I want to remind you that this Friday, we are going to be doing a complimentary machine learning masterclass. And all the proceeds of this donation-based program will go towards relief efforts in India. As you all know, India is being hit by the second wave of COVID, and the new strain is extremely viral, and it's causing a lot of damage for people throughout the country. So we're trying our best to see what we could do to support some of the relief efforts which are going in there. So please generously donate if you have had the benefit of taking these classes. And we're trying to do these afternoon sessions in a complimentary mode. So if you've had a chance to attend our classes and it's been beneficial, please contribute whatever you can so that we can try and make a difference for the community. And we'll be spending or afternoon on Friday to basically share one of our modules in the machine learning program to help make the difference. Last but not least, we also have another webinar which is going to happen at 1 o'clock. So this immediately happens after this one. So that's in partnership with NVIDIA, WEF, WAIFC. If you're interested in continuing on, I'll share this link again at the end of the session. Please feel free to join us for another session. And also, before I hand over the stage to Rami, I just want to give you a quick reminder that our next session is going to be on June 1st. And that's with Pitogram, who's going to be talking about alternative data in investment management. So I hope you join us, and I hope you learn a lot in today's session. Rami, please take it away.
Thank you. Let me try to share my screen. I need a permission for sharing.
Oh, I'm so sorry. I thought I did. Give me 1 second. Okay, so try it now, Rami.
Thank you. Okay. Can you see my screen?
Yes, we can. Yeah.
Okay. I will go to full mode. Okay. And I will put a timer that I will keep speaking without stopping. So thank you everyone for joining today. Thank you, Shri, for inviting me. So today I'm going to talk about my experience from attending the 30-day chart challenge, which is a data visualization challenge that occurred in April. And it was basically my first. There are many challenges that occurring in the internet, mainly in the last year. It was my first one that I joined. So I can try to share my learning from this experience and advocate others to join other data challenges. So before we start, just a brief introduction about myself. I'm a data scientist, data science manager. I mainly was, as the pictures you can see on the right side can indicate I doing a lot of R, time series analysis, and wrote a book about time series hands-on time series analysis with R, and also contribute to the R language with creating applications for time series analysis. So with that, the agenda for today, I'm going to talk a little bit what was the challenge and what was the motivation for anticipating this challenge. Kind of like before we jump to look at the plots that I made, kind of like my view of what is data visualization and what this field is about. And then before we end, hopefully to have some time for Q&A. So what was the challenge? The challenge was occurred during April, and the idea was to create for 30 charts, one for each day in April. And there were 5 categories: comparison, distribution, relationship, time series, and uncertainties. And for each one, there were different tasks. So for example, if you look at the distributions, day 7 was about physical, day 8 was about animals, and so on. So it was very wide and open topics that each one could choose whatever he think suit or related to this topic. And really the credit for creating this wonderful challenge is for Cedric Scherer and Dominic Roy. They are amazing visualization people. I would recommend to follow their work. Cedric and Dominic both are doing most of their visualization in R. I would say that most of people that anticipate this challenge are coming from the R community, but not all. There are people from JavaScript background, Tableau, Python, and other tools. So what was my motivation to attend Data Visualization Challenge? So my first motivation that I've been trying to join some challenge for a while, but I didn't have time. So if you think about all the Kaggle competitions, the machine learning competition, the M5, M4, M5 competition that is in my domain, time series forecasting, I always had a problem that I just don't have time. And usually those challenges are consuming a lot of time, which most people work full time don't have. So I thought when I saw the challenge that is data visualization, and I'm doing a lot of data visualization, I'm writing packages for data visualizations. I thought maybe it's a good opportunity to show the tools that I'm creating, and also to have some fun joining some challenge. And that was the main motivation. And if you think about the data visualization, and this is something I knew before, but I learned more while attending this challenge, data visualization is a really wide field. I'm kind of like on, if you look at some kind of a scale, I'm on the left side. Data scientists using a lot of data visualization. Before you're doing any modeling, you want to check your data, see that, check some assumptions, identify patterns. Data visualization is definitely one of the tools that you want to use. And by day, you're doing dozens, if not hundreds of plots to explore data. And typically, like data scientists working with R and Python, and the implication is the ggplot2 is one of the main packages in R. Boken and matplotlib in Python, and plotly is kind of like agnostic package that available both in R and Python. And on the other side of the scale, you will have the data visualization designers. And this is typically people that I would put them as artists. They're doing amazing visualization that is it's more artistic. They have more, you see, like when I say work of some data visualization designer, you're like, it's like, wow, it's amazing. And it's very, using the tools that I'm typically using, the ggplot or plotly, it's very challenging to get to the same results. And typically they are using tools like Adobe Illustrator and other advanced graphic design tools. And in the middle, you can find all the business analytics, data analysis that may use either also R and Python or Excel, Tableau, Power BI, and somewhere toward the data visualization designer, you will find the data journalist, which is kind of like a new field, but it's amazing to see what they are creating. So if to summarize it, data visualization, it's more than just plots. It's multiple disciplines. And I think that if you want to understand the difference, if you look at plot, and my role of Fang, that if you look at plot and it takes you more than 3 seconds to understand what the plot is about, assuming that you have the context of the plot, so it's probably going to more to be the artistic level. And if you less than 3 seconds, so the plot's probably doing a great job in explaining what you're trying to sell. And there is a trade-off between interpretation and complexity. And typically, data scientists are on that level. Our plots are much more simple. You have X and Y, and you have some scatter or you have a line, but they are kind of like, typically the message is very clear. The data visualization designer, I probably will put them on the complexity, where I think they can draw amazing plots, but the interpretation is hard. Sometimes it's very hard to understand, or it's take more time. It's more like something that you would put on the New York Times or Financial Times, some complex plot about some topics that is may stimulate the reader to go and dive to some article, or look at the small details of the plot. So those kind of like the way I see it, the difference between my perspective as a data scientist and the perspective of like the other scale of like the professional people that are doing visualization. And I think it's very challenging to keep the plot with high interpretability and use also high complexity. And this is, I think, the main challenge when you're trying to combine the two. The nice thing about this challenge that you see all of those, and you get to learn from all these type of people that different backgrounds. So with that, let's jump to some of the plots that I created for the challenge. And I will start. That was my first plot, and you can see also the progression in the plots that when I'm using that I will show today. The first one, and this is probably I would consider that it take more than 3 seconds to understand what's going on over here. But this is a Sankey plot. It's one of my favorite plots, which enable you to show distribution of quantitative data over multiple categorical variables. So to make it much more simpler, in this case, this is a summary of the type of airplanes landed in SFO during 2019 by different categories. So it started from the region that they land from. So you see the US, where most of the planes that landed in SFO, San Francisco Airport, came from the US, domestic flights. And then you can see like the distribution between passenger and cargo, the type of the manufacturer of the airplane, Boeing, Airbus, and so on, and then like the models and the type of the body. So that's kind of like was the starting. I think I used the default options. I did it with Plotly, and I used the default, so you can see like when I look at it now, I say like maybe I should use a different title, like the title should be bigger, or I might change the color scales, but kind of like that's kind of like the progression. You will see like more advanced plots as I will go to the next slides. The second day was about Pitogram, and this is again like something I knew it exists, but I never really dive into it. It was not something that I care much before, but it was really nice to learn how to do it. And Pitogram, as you can imagine, is using a diagram with pictures. It's a combination to send some message. In this case, this is the distribution of generation of electricity in the US by energy source. And I think the picture is kind of like, very simple to understand. Most of the energy source is coming from natural gas. Then the second is the nuclear energy, coal, and so on. To create this plot, I used, and this is the only plot I used with Untitled Chapter, which is a great it's a great JavaScript library, which has a wrapper in R. And the third day was about historical. And here I decided to challenge myself. And if you're familiar with R, R as base R, which is enable you. There is also like a graphic functionality, which is pretty primitive. So I decided to do a full plot with the labeling and everything with base R. So it took me like the code, it's like 3 or 4 times or 5 times more challenging than like you just doing it with something like a Plotly or ggplot2. But it was fun experience, like it's something I would never do in my day-to-day work because it's just not efficient, but just to show that you can add colors, titles, labels to base our plot functionality. In this case, again, plotting the annual consumption of natural gas in New England by states. And you can easily see like trends and, the size or magnitude of each state. I think, Shri, you are in Boston, so you can see how much Massachusetts is using a lot of,
Yeah,
it's the biggest.
we're all crypto mining.
Yeah, probably.
Or maybe it's also that, we use a lot of heating, I guess, for natural gas. So it's in the
I assume also population, it's also like the population size is kind of like playing a role. Massachusetts is probably the biggest state in New England, so it's assume definitely compared to Maine and Vermont. So
absolutely, and it's kind of not very. Connecticut has been increasing its use of natural gas. I don't know what's the reason from 2000 to 2020. We see some kind of a linear trend.
But potentially they might start to produce more electricity from natural gas. Could be. I'm speculating. I'm not sure. And this data is coming from one of my favorite website for data, EIA.gov, which is a website, energy information administrator, provide a lot of data about
administration. Yeah, that's the gold source of energy data in the United States.
Yeah, a fun website if you love time series data. And then it's coming to Sankey, and this is the last time I use Sankey. If you let me use, if you won't limit me about like the type of visualization, probably I will continue to use Sankey. So I decided this is a good opportunity to use Sankey, but it was the last time I used Sankey. And the topic here was magic. So I found on Kaggle a data set that provide information about the characters in all Harry Potter books, and it's kind of show the distribution of all the characters. So it started with either is it student or not, male, female, the house, the eye color, the blood type, and the results like in the end of the book, did they survive or not? So again, this is kind of like Sankey. I think it's a good a tool to describe a flow of categorical variable, multiple categorical variables. The next day was slope, and I think and this is where I kind of like, because I'm coming from heavy statistic background and time series, so you can see a lot of the influence. And again, like people, when you have a topic, people make their own interpretation about what should be the theme for the plot. And here I just show different way to calculate slope or fit trend, with the difference between simple trend calculated with linear regression and the one that you can do with the piecewise regression when you're setting knots and then enable to capture better changes in the trend of the data. And this is data is the total US construction spending, monthly, non-seasonal adjusted. And here I choose a black background, which kind of like I like to use, make it much more interesting than just a white or gray background. Next day was experimental. So here I show like a plot. Shri mentioned before that I had presented about forecasting the demand for electricity, and I had to create for the forecast confidence intervals. The problem that I use a model that does not support with providing a prediction intervals. It's a GLM. So what I did is just simulate it with backtesting on the testing partition, the residuals, and use this to capture the distribution and calculate the prediction intervals for the future forecast. So it was, again, like a fun exercise. Make it dark background looks much more interesting than it actually does. And here I started also to add annotation, which is a painful process, which is not as trivial. And I think like most of the time I spend on the plots, and you will see more advanced plots and at the next slides, it's not about creating the plots or the colors and background. It's more about adding annotations to the plot, make it much more challenging. This plot is describing, so the topic, the theme was here physical, and describing landing of meteor in the US since the last, I think, 100 years, or it was discovered during the last 100 years. So those are the landing location, and the color is the magnitude. Now, people ask me if you can draw conclusion. I think about like the probability of getting. It seems like that the Midwest is getting most of the hits, and I just think that probably like there are more that we did not discover. So it's not really good. It's not a representative of all the meteor. Maybe someone already did the research, and again, it's like I select a topic that I don't have a domain knowledge or previous background. It was just interesting to plot, so I spent a few hours, found data on NASA API, pull it, and plot it. This is about distribution. The topic here was animals, so this is the distribution of an endangered species in California. And I use here, it's called tree map, or I think it's the name of the plot. It's also good, nice method to show distribution if you have some variable and you want to show how it's distributed by some categories. Again, like statistic is kind of like my main background. So I think this is going, so this plot is going more to I try to go inspired by data visualization designers and create some kind of like a story. So this is kind of like where I think that it will take more than 3 seconds to understand what's going on over here. It's also has a lot of text. And it's more like, it required more effort to understand what's going on over here. So over here, what I did, I describe seasonal analysis in time series is like one of the key components. When you're trying to understand what's going on with your data, try to learn about seasonality. And there are multiple ways to understand the level of seasonality. And usually the question is to trend or not to detrend the series. And I try to show like how, if you're using some kind of like distribution of the data by the seasonal component. Here, in this case, this is the US natural gas consumption and the distribution by demand. What would be different if you detrain the data or not? So you can see that the upper box plot is wider, and when you remove the train, it becomes narrowing, and you can see more. It's provide a more clear view about seasonality. And creating this type of plot, it's like most of the work is about adding those small annotation text. It's taking a lot of time. I think it's about 400 lines of code, and it's not. I would say it's not as trivial to do it in normal programming language such as R or Python. On the abstract, I plot the distribution of COVID. So this is kind of describing the ratio between recovery rate of COVID cases and death rate by country. And the size, it's a bubble chart. The size describing the magnitude of like how many cases the country had. So technically, as you are on the upper left side, it means that most of people recovered and you have a low death rate. And when you're going to the lower right sides, mean that you probably don't handle well the pandemic compared to other countries, as you tend to have more people are like the death rate is higher than other countries, and your recovery rate is low. And again, this is kind of like abstract, so I remove the grid lines, try to make it very general. That was a fun plot. I don't know how many people are familiar. This is using a polar plot, which is using a circle to describe some variation over some units. So in this case, the variation is over time. So it's describing 365 days and showing the consumption of electricity during 2020 in California. So you can see that as you're getting toward the summer time, the consumption increasing. It's on the lower left side. And during the winter, it's more consistent, meaning people using less electricity to heat their houses, but the main consumption is probably coming from natural gas. So electricity is very consistent during the winter, but it's really related tight to the temperature during the summer when people are using AC. This plot, and I probably won't go over most of the plot because I want to leave some time to Q&A, but this plot describing the distribution of COVID cases by continent. And I was inspired by there is similar plot that if you Google the Financial Times COVID-19 tracker, they create amazing visualization for tracking the COVID-19, and they had a similar view for this. So I just wanted to create something similar using, the background is the Financial Times color theme, and try to, this is a work inspired by a work of a data generalist doing a really amazing work. This again, very similar to the seasonality analysis, just explaining a concept in time series about correlation, how the ACF function is, the autocorrelation plot is working. And again, it's one of the things that you take more than 3 seconds. You need to read and understand what's going on, especially if you don't have a background. I would say that this is probably like my favorite plot from all the work I did. So this is describing, and the topic here was space, and this is describing near Earth objects. So again, I want to do something about space. I don't have background in physics or anything that's related to space, so I just went to NASA website. They have a great API, and I found this data set that's describing all the asteroids and comets that are being tracked, that are in orbit around Earth. So there are some unit of measurements to that they measure, like the distance from Earth, the magnitude, their size, and you can see that based on some criteria, some of the one on the left box are the one that potentially to hit Earth, so they are classified as potential hazard asteroids. And basically, it's like they have a low magnitude, and their Earth minimum orbit, the distance from Earth is close enough that they can actually go and pulled by the gravity of Earth and land inside. So it was a fun plot, and again, it's like to create all those annotation was really painful, and again, it's kind of like 400 lines of code. That most of it, by the way, is the annotation. And I'm getting toward my time, so I will just pause on this, and then we'll go to Q&A. This is again like trying to do like something similar to the posts that you see in the Financial Times. I really love their work, so I get a lot of inspiration from their work. In this case, I'm showing the sales of alcoholic beverage in the US, the monthly sales, non-seasonal adjusted. And you can see what I wanted to show you, how the pattern changed during 2020, during the pandemic. So you can see that every year there is a pattern, people consuming a lot toward the holidays. People buying, you're going to the holidays, you're buying more alcohol, you're consuming more. And then after you finish, starting January, that's it, like it's really dropping until the next holiday season. And during 2020, it was something different. You can see that since March, the consumption is like every day is a Christmas, and sales increase significantly, and probably I can speculate due to the COVID-19 pandemic. So this is again like a very heavy plot and time consuming to create. So I will skip those plots, and I want just to leave time for questions. And so I will just summarize, the key takeaway. I think that it was fun to get exposed to different data visualization approaches. Especially, I'm coming from a field of data science that we love to look for insights, but to get exposed and inspired from data journalists or the big designers, and try to mimic their work was really the main lesson from this exercise for myself. Improved skills, like learning how to annotate was fun and also time consuming, but it's kind of like something that I may use it in my work when I want to present something for some stakeholders, non-technical people. The time consuming is probably like the downside of it. So I started, when I started, I thought like, I saw the topics, I have packages I wrote on, all the energy stuff, or COVID stuff. I took a data from packages I wrote. So I thought, it's be easy task. But then like, as I started to work, and I try to maintain some standards that increase from day to day, it's become more time consuming. And the first week I was doing the spring break, I was off. So I could create a plot every day. But when I went back to my work, it was much more challenging. And then like it's kind of like became like a weekend stuff. So this is the downside of, I wouldn't say downside, but like if you're going for a challenge, you need to be aware about it at the time or the effort that you are willing to spend. The other takeaway that I really want to learn JavaScript, I know it's basic JavaScript like a D3, but I think the main visualization is done in D3. This is the main tool. And last but not least, it was really a fun experience, and I really highly recommend people to join some, especially like, if you're a data person, to join some of those challenges. I have these links for some of the resources that I use. So first is the code. All the plots that I show you are available in the repo. You can go and reproduce it. I didn't finish all the 30 days, so I'm still trying to catch up with some of the plots that I'm missing. So code is available. You can reproduce it. There is also more data visualization I have in my Instagram that dedicate for data visualization. The challenge website, you can find code of other people or the visualization people that contribute. Really nice to see what other people did. For visualization, I mainly use Plotly. So here's the link for Plotly, the R version. There's a Python version, of course. iCharter is another tool I used, and Leaflet for the mapping. So those kind of like the main tools that I use during this challenge. So with that, I will pause here and see if there are any questions.
Yeah, thank you so much, Rami. This was very exciting. Did you take a whole month off?
I spent, it spent a lot of my time during this month and after. So I still keeping kind of like the plots that I'm missing.
Nice.
I really want to get all the 30.
Nice.
I have 20-ish, but trying to get the remaining.
Absolutely. And thank you for sharing the code. I mean, it's one thing to get inspired, but also being able to like replicate it and build upon it is very much appreciated. I think many of the participants will try to like, maybe fork your repo and then build upon it. So I think we have a couple of questions. One, the dreaded question you probably always get asked, like, what are the pros and cons of R and Python? So I don't know, we can probably have a whole session on that. But what do you think? Do you feel more comfortable with R compared to that of Python in this? Or
so I would say in data visualization, I'm using R because I'm doing a lot of statistics and time series, and for this domain, this is one of the best tools for that. Python has also application. Like if you're coming from Python, you find probably most of the things that you need in Python. Data visualization, I think that R. So in statistic and data visualization is like where R was always one step behind Python.
Mhm.
You can see that a lot of Python libraries are kind of like derived from the R version. So ggplot2 it's called like the grammar of graphics in R, and it's one of the main, and it's amazing package for data visualization. I would say that I'm not using it because I'm kind of like not against, but I think that data science is like using it's not interactive, so I prefer always to use interactive. There are advantages of using interactive, so I'm using Plotly, which Plotly is available both in Python and R, and it's more or less the same. So I would say that if you are already a Pythonic person, you have enough tools in Python to create visualization. At the end of the day, most of those applications are based on JavaScript, D3. So if you are really into data visualization, go learn JavaScript.
Okay, good. And how do you kind of see visualization, the ecosystem grow? Because, we have seen dashboarding, and with the ease of building out dashboards, everybody wanted to build it. And I said BI is now becoming BS was the statement. because it's so easy to drag and drop. And whenever I see my students just drag and drop and like, oh, you have another graph, but a lot of time is spent on the visualization, but very little time is spent on the actual analysis of the data. So how do we do the balance? Charting and graphing is one aspect, but then also how do we go about, focusing on the root concepts in the analysis aspect?
Yeah, that's a good question. As a data scientist, you definitely will meet it. Like most of data scientists are. So not all. So I would start. Not all data scientists are building the dashboards, but you definitely, if you are doing a modeling, you need to do some descriptive analysis. So you will have to visualize it, the data in some manner. So I think that you will meet it in you will have to use data visualization in your work as a data scientist or data analyst or business analyst. And then the other component is the dashboarding, because I think that if you are not able to communicate your results, so then kind of like if you keep it to yourself, it's not worth it. So it's important. I think both of them are important. Not necessarily like in big teams, not necessarily that the same person will do all. I would call it like a full stack data scientist is the one that can do both. Descriptive part, and also then when you need to communicate to build some dashboard report, and the emphasis is the data visualization, I think.
Absolutely. And how much do you see, in the context of dimensionality reduction and using things like piecemeal and ways in which you could reduce the amount of data so that you can make it easy. How much of it is actually done in practice? I mean, do you use a lot of these kinds of tooling in your job? Do you feel like data scientists need to be more versatile with visualization, or do you think it's more of an end product of all your work and you are using these as a means of communicating the insights to the outer world?
So I guess it depends on the context of what you are doing. I think when you are working and you're trying to understand the data, you may or may not reduce dimensions. When you're talking with stakeholders, and this is going back to complexity, if you go with some multi-dimensions plot, it will be harder for non-technical people to understand. So I would say like this is where important like to do the data visualization dimension reduction to simplify, to make it easy to understand. Sometimes like if myself, I'm trying to understand, I understand like the context and I have the technical skills, so I may do some complex visualization to understand something. So I guess it depends on like who is the audience.
Absolutely. Cool. So I'm going to be spending some time later this weekend looking at your GitHub code so that I can refresh my visualization basics, but also get a chance to try out and also experience some of the design aspects of what you've been building. Thanks so much again, Rami. I know it's our second session in this year, I guess, but I really enjoy listening to all the cool things you've been building and all the work you've been putting into it in your spare time to help kind of spread the word in the open source community on the power of all the tooling which could be done. So thanks again for all the people who have been listening in today's session. I hope it was useful. Again, quick call of action. If you've been attending our sessions and you have enjoyed learning with us, please try and contribute back to the Q for India efforts. We don't ask much of you, anything from our audience, but this time around, we're trying to see if we can raise both awareness and also contribute some of it to the relief efforts back in India. So if you can, please take a look at quforindia.splashstat.com, and I would really appreciate your support. So if you're going to be joining us, we have a 2-hour masterclass on machine learning and AI for finance this Friday, and I hope I will see you soon at that time. Otherwise, there's another session next Tuesday with Dr. Pitogram from New York University, and he's going to be talking about alternative data. So we will see you then. Thank you for your time, and I'll see you soon. Take care. Bye-bye.
Thank you.